All right, our next trigonometric, there we go. Our next topic in our trig class is using inverse trig functions. So basically, if you know what these two sides are, how can you figure out what the angle is? Okay, so let's take a quick example. We'll come back to these definitions in just a second, okay? So looking at our table, basically what we're looking at here is that you'll be given two sides, which means it's going to be really easy to find this number here, right? So you'll take your two sides, you divide them to find the ratio, and you get one of these numbers. And then you can look at it and say, okay, well, if I know that when I divided the opposite side and the hypotenuse, I got this as my answer, well, then that means it has to be a 15-degree angle. Okay, so let's look at these examples right here. So this one, they tell you that the sine is 1/2. So the sine, that's my opposite over hypotenuse, is 1/2, which is 0.5. What's the angle? Well, it's 30 degrees, right? Because that's what my table tells me. So I know that this one's going to have to be 30 degrees. Okay, this one tells me that my tangent is 1.428. So my tangent is 1.428. So what's the angle? That's a 55-degree angle, okay? Because that's what my table tells me. Okay, so that's all that we're doing here. Okay, but like we've said before, this table has a lot of limitations. It's easy to lose. It doesn't have all the angles. So instead of using the table all the time, we use these buttons on our calculator. Okay, so primarily we're going to be looking at how do we use these calculator buttons to figure this out. Okay, so let's come back up here to these definitions, then we'll take a look at these. So if the sine of an angle is x, then the arc sine or the inverse sine, so it's a sine with a little -1 as an exponent of x equals theta. Okay, so if you know that the ratio is x, then you take the arc sine of the ratio and that will tell you your angle. Okay, similarly with cosine, if I know that the cosine of an angle is y, so I know that the ratio is y, then if I take the arc cosine of that ratio, that will tell me the angle. Okay, and lastly with tangent, if I take the arc tangent of the ratio, it's going to give me my angle. Okay, so when we look at this guy right here, if I know the sine is 1/2, we use the table to figure this out. But if I was using my calculator, how would I figure this out? Well, I would plug into my calculator the arc sine of 1/2. Okay, well, how do you do that? Here's how. Okay, if you look at your sine button, see how right above it, it's got that sine -1 right there? That's the button that you want. Okay, so I'm going to do second and then the sine button to get your arc sine. There's my 1/2. Hit enter, 30-degree angle. Okay, so that gets us the same answer that we had. Okay, similarly on this side, or this problem, the tangent was this, so we want to find the angle. So I'm going to do the inverse tangent of 1.428. So on my calculator, second button, and then tangent, and then 1.428. Okay, and now you might be looking and saying, oh, Miss King, it's not exactly 55 degrees, right? But remember, that's because the numbers that we got in our table, these are rounded numbers, right? If you rounded this number to the nearest, let's see, these were rounded to the 10 100,000th spot. If I rounded this to the nearest 1,000th spot, yeah, it's close enough, okay? So this is going to work out to 55.0 degrees, we'll call it. So it rounds. Okay. All right, so that's how we're using this. So now let's take a look at when you're looking at this at a triangle. So I'm looking at this triangle and we want to try to figure out how big is that angle. So just like we have been, the first thing I want to do is just label which side's which. So this has to be my hypotenuse because it's opposite the right angle. Here's my angle. This would have to be the opposite side. This is the adjacent side. Okay, and I know the opposite and the adjacent side. So I know the opposite over the adjacent. Which trig ratio is that? OA SOHCAHTOA. That's tangent. Okay, so I know that tangent is opposite over adjacent. So that means that I know that the tangent of my angle has to be 5 over 12. So to figure out what the angle is, I'm going to do the arctangent of 5 over 12. Okay, so arctangent 5 over 12 is about 22.6 degrees. So that's how big theta is. All right, and then this last guy here, we're going to solve this triangle. So anytime it says solve the triangle, that always just means find all the missing sides and angles. Okay, so that's what that means. So this guy right here, I already know that one. That's 90 degrees. Okay, so I need to find all of this information. So the first thing I'm going to look for is I'm going to figure out what this missing side is. You could do the angle first if you want to. I just want to do the side first. I know these two sides. So since I know the two sides, I don't need any trig at all. I can figure this out using Pythagorean theorem, right? Okay, so to find the missing side, I'll use my Pythagorean theorem. All right, I know that this guy's my hypotenuse. So I'm going to say that 6 squared plus 8 squared equals my unknown squared. Let's see, that's 36. 8 squared is 64. 36 and 64 is 100. And then the square root of 100 is 10. Cool. All right, one piece down. Okay, now we got to find an angle. Okay, so let's see. I'm going to call this one. I just picked one of the two. I just like that angle better than I like that angle. I have angle bias between the two of them. So I'm going with this angle. All right, and I have all of these sides, so I can use whatever ratio I want. I could use that I know that the sine is 8 over 10. I could use that I know that the cosine is 6 over 10. I could use that I know the tangent is 8 over 6. I wouldn't want to use secant or cosecant or cotangent because I just don't have handy buttons for those on my calculator. So I'm not going to go with one of those. But let's see. We use tangent here. We use sine there. Let's use cosine. I'm going to use cosine for a while. Okay, so to find our angle theta, I want to use, let's see. So I'm going to say that the cosine of my angle, right? Cosine of this angle would be adjacent over hypotenuse. So it would be 6 over 10. So I'm going to find the arc cosine of 6 over 10. So the arc cosine of 6 over 10 is 53.1 degrees. Perfect. Okay, so now I know that this angle right here is 53.1 degrees. Last thing I need to find is just this other angle. Well, we could use our trig ratios and totally get it that way. Or we could use the fact that we know that all three angles in a triangle add up to 180, right? And since I already know this one's 90, those two have to add up to 90, right? So I can just say, well, let me do 90 degrees minus that answer that I just got. Well, that's about 36.9. So for my last angle, right, the easiest thing to do, so I'm going to just call it the second angle, right? I know that the two angles are complementary, right? So all angles, so the three angles add to 180. So I did 180 minus 90 minus 53.1. So it's 36.9 degrees. And there we go. We've solved our triangle. Okay, so again, solving triangle means find all the missing sides and angles. Okay, and we use this using our trig. And again, the whole thing here, what is this inverse trig functions? It's just going backwards on the table. All that an inverse trig function is it's instead of saying, I know the angle, tell me the ratio, it's saying, I know the ratio, tell me the angle. Okay, so when you push the sine button, you take a sine of this to figure out these numbers. You use arc sine from these numbers to figure out the angle.